Thank you very much. Thanks for the introduction. Good morning, lady and gentlemen, the ones who are remaining. It's not always very easy to come on podium which has just been vacated by not one but two beautiful ladies, both being lawyers. One of them had a very good smile on her face when she said, "Keep calm." They really asked for a lot. Yeah? Nevertheless, I will go by what the other lawyer did say, a disclaimer. So I would say that whatever I say today is on a very without prejudice basis. And it's a highly technical subject, and a lot of research has been done by so many entities in the past that when I decided to take on this topic and me and my team took on the project research work, we found so much of information, a plethora of it, and we found it difficult to sort what to take, what not to take. Nevertheless, we did our level best, and we have put together a presentation which I am sure will raise eyebrows and really focus on the matter which is under very, very severe consideration. Metamorphically, if I say, when we hear a child cry, the first tendency would be to close the mouth of the child or maybe to ask the child to keep quiet. But that's not the solution. The solution is, why did the child cry? And what is the symptom? And what is the cause? That is where we need to focus our energies and our expertise on. Without much ado, I will proceed with my presentation. We have been hearing quite a lot in the news about few topics over the past many years which are related to the topic of my choice today, which is very much in sync with the topic of this conference, New Energies in Marine Surveying. My topic, gentlemen, is catalytic fines in fuel oils and their repercussions. I am going to refer to some of the notes because it is highly technical and not everything can be kept in the mind. And I would like to be as precise as possible, so pardon me for indulging in it. Yeah. We have been hearing quite a lot in the news flashes about operators to be told to take responsibility for cat fine damages. We also hear other news about bunkering related issues where there are quite a few cases coming up where substandard bunkers or inappropriate bunkers have been termed as a possible attributed cause for a damage. So what does all these do? And what are the repercussions? The repercussions directly are on the cost. The cost to the owners, to the hull and machinery underwriters, and to all the parties who are concerned. And research done by BMT Salvage and by many of the P&I clubs, of which I'll be taking excerpts once in a while, indicate that 43% of the incidences that have happened in the recent past are related to the machinery. And not all are attributable to the catalytic fines, but most of them and many of them definitely are. The average cost which main propulsion machineries have incurred losses in over the past 10 odd years has been increasing, and increasing with a trend. Like I said, whenever we see some symptoms, the symptoms are indicating something. I'm sure in all your years of sailing and indulgence in marine accidents or incidents, you must have seen that unless it's an act of God, every incident gives an indicator. There is a symptom to say that, yes, I am coming. Due diligence helps us to identify that symptom. Due diligence helps us to mitigate whatever is going to be the outcome of that damage. So a trend has been seen in the machinery damages over the past 10 odd years. And what do these trends indicate? They have a very clear benchmarking which points to a major question which is rattling the industry and which is going to be the point of discussion today: catalytic fines. To understand what catalytic fines are, we have to realize the definition of a catalyst. A catalyst is that product which brings about a reaction between two elements without actually taking part in the reaction. The reaction wouldn't have happened if the catalysts were not to be there. However, after A and B react and form an end product X, Y, and Z, the catalyst loses its importance. It is not required anymore. Nevertheless, without that, the reaction would never have happened. So this is a fundamental problem. This catalyst, which brought about the reaction and is not required any further, becomes a residual waste, which is an impediment to proper operations of the marine engines, especially medium and high speed engines. I will come to that in the subsequent sections, but this is the residual catalytic fines. Many of them, the technology has been advancing day by day, and there have been ways and means of removing these residuals. Unfortunately, not everything can be removed. Some still find their way into the end product, which is the main cause of the problem that the industry is facing. So, what are catalysts? We have understood that. And in processing of crude oil, from its stage of crude oil to an end product, we use products. The refineries use catalysts made of silicon and aluminum compounds, which are required for the refining process to get end products like, say, petrol, kerosene, diesel oil, and any other such product. If you see the slide here, the crystallization process out here, this is where the catalysts are used. And by the time it comes down into the end products out here, the catalyst has now become a residual unwanted stuff which needs to be taken out. And the challenge of doing this is what the industry is facing every day and night. I'll just delve into the historic facts of how the marine fuels evolved. Initially, way back, it used to be these canoe boats which were made from the bark of a tree. Those were the days of absolute bliss. There was no fuel, no petroleum, so there was no pollution and no such reactions. However, they were not adequate with the changing times. So it graduated into more modern ways of transportation, sails, and little bit of mechanization, and then a little more of mechanization till we reached a stage where steam engines and diesel engines were innovated. This is where the problems started. This is where, if I may say, the origin of the catalytic fines commenced. Because when we use diesel, it has to go through a process of crude oil refining. And this changed over a period of time because of recession and so many other ways where the diesel was expensive and not commercially viable. As a result, the industry and the refineries had to go through further processing to allow a more economically viable product like fuel oil to be used as a bunker. So like I said, since 50s, when the diesel engines were converted to residual fuel, catalytic fines have been there. But the repercussions were not so strong in those days because there wasn't much awareness and diesel oil was easily available and cheaply available. To understand more what catalytic fines is, I have just got a graphic of a strand of hair. A strand of hair is having 50 to 70 microns as its thickness. Microns is the unit used for measuring the size of a catalytic fine. So 50 to 70 microns is the size of a hair. And what regulations need is a maximum of 20 to 25 microns of any molecule of a catalytic fine. The filters that we use are able to remove up to 40 microns or say up to 45 microns. But how do we remove microns which are much smaller than that? To do that, we got to go into more advanced ways of refining. And more advanced ways of refining calls for further chemical usage and more are the expenses involved in that. A typical filter, like I said earlier, is not able to remove the finer particles of cat fines. This gets embedded into the filters and it passes into the injectors and into the engines. The cat fines, as you can see on the slide in front of you, have been up to 5 to 10% of them finding their way into the end product at all times, in spite of the facilities that we have with us at this stage of processing. So what do these cat fines do? This is a typical graph of a, if I may show this is a cylinder liner and this is a piston ring. So this is the film of oil which has to be maintained between the liner and the piston ring. The importance of a good lubrication is very well established and we all know that. However, if a small particle finds its way into the system and if the size of that is much bigger than the clearance, like here we have got for illustrative purposes 10 microns, whereas this is much more than 10 microns. So what happens? There is no alternative. It acts like an abrasive. It acts like an abrasive and starts polishing the surfaces of the piston ring, starts polishing the inner surface of the cylinder liner. In the process, what happens? It becomes a mirror finish. The cylinder liner becomes like a mirror finish. And when there is a mirror finish, the retention of the oil film is lost. For those who are in the know of the metallurgical status of a piston ring or of a cylinder liner, will realize the inner surfaces of the liner are not mirror finished, they are honed. They are honed and serrated for the simple reason that it should be able to retain a film of oil. If it is very smooth, the oil just slips out and then there is a metal to metal contact and the wear down is accelerated. It might be shocking, but a wear down which is anticipated over an years of running can be experienced within weeks if the fuel being used is of substandard quantity. If the catalytic fines in the fuels is of a very high volume and it can really eat into the system. So this is a typical example of the slide that you see where the cat fines are embedded in the laminal of the cast iron cylinder liner. So it acts as an abrasive and starts polishing the surfaces, which is very, very detrimental to the lubrication which we are rightly required to be given to the engines. Now there are problems with the catalytic fines. Why do they find their way? How is it that they find their way in spite of all the crystallization processes, in spite of all the preventive measures that we have got in the refineries and on board ships? Why do they still find their way into the system? It's because the specific gravity is close to that of the oil. So it blends very easily and not very easy to separate it. Their size is too small. The bigger particles can be trapped, but some of the smaller ones which are presently unable to be trapped do find their way into the system. The hardness is higher than the wear down property of the liner or the piston ring. So the catalytic fine prevails over the material. Okay, I'll go into some more graphics. Why there is so much of hue and cry about catalytic fines? We all know that there are symptoms which are there, but why so much of hue and cry? Over the past so many years, especially in the past 12 years, researchers, these graphs are not mine. I have taken it from different GH reports or from the club newsletters. If you can see, there has been a marked increase in the years 2012, 2013. Why so? Why did this happen? It's because during the recession, the cost of bunkers increased phenomenally. The filtration process was not as adequate as it has to be. The demand for a cheaper bunker was very, very high. So the quality took a beating. There was definitely a compromise on the quality of the bunkers that was being supplied globally. That is why the trend shows very clearly that after the recession, the damages due to catalytic fines were increasing indeed. There are quite a few standards which are existing. The ISO standards, I will not go into the depths of it because I can see we are running out of time. But then there are standards where the fuel oils that are being supplied on board have to meet certain criteria. However, they are not adequate. They are not adequate, but then it is there. There are equipments placed on board vessels or in the refineries which are able to filter the fuel before it goes to the end product. But however, again, the demand for finding it up to 15 ppm here, we do have up to 60 ppm, we can filter the fuel, but 15 ppm is very difficult to filter, although newer equipments are coming into the market. So what are the solutions that we are looking at? Are we looking at solar power? Is that a viable solution? Or are we looking at some other source of alternate energy? Like this? Okay, there's a technical glitch here. I would have preferred Quest Marine to be on the sail, however it's out on the water. So these are the small glitches that the industry is indeed facing. So we are looking at solutions. We have got problems which ships and ship owners are facing. We have got different set of problems which underwriters are facing. We have got different set of problems which surveyors are facing. I've been reminded about the time, so I can't go in details into these problems, but the fact remains that every facet of the industry is facing a different problem. But all of them realize that the negative impact of CAT fines has to be identified very clearly, and we have to snap it in the bud as much as possible, because a cost of changing one liner on a two-stroke engine on an illustrative basis like this can be equal to the cost of this car. We would rather buy a car than change piston liners and units every now and then by being a bit more diligent. So why do engines get damaged? It's because of, went over it in the previous slide, scoring of the cylinder liners, embedding on the softer metal surfaces of the engine. So the problems which ship owners face is early wear and tear of the machinery before time. Useful life of the engine equals to vessel's life. However, if CAT fines and the poor fuel quality is used on a predominated basis, the life automatically reduces. These are the problems faced by the underwriters. We can discuss about it in a later stage. These are the problems faced by surveyors. We will discuss it in the next few seconds because it is more pertinent to us since we are the surveying fraternity. These are all problems which can be seen and solved. These problems are seen and solved. There are many people involved in it. But there are some problems like catalytic fines which cannot be seen, and the solutions are much more difficult. There are problems which can be identified easily, solutions are difficult, but catalytic fines, identification itself is difficult, so the solution is far more difficult. One of the things is newer equipments which are coming in where we can have the onboard analysis system which is able to monitor the percentage of the CAT fines in the fuel oil at different stages. Other measures as a trigger will be timely analysis of fuel oil, running 2 purifiers in parallel instead of just one, inspection of fuel system filters much more often, storing newer bunkers in separate tanks and not allowing 2 bunkers to mesh into the same tank, taking drip samples instead of any other way of sampling because this is more representative, draining water from the service and settling tanks on a very regular basis, preferably once in 4 hours, and not allowing the drained residues to go back into the system, and regular maintenance of the fuel treatment system. Conclusions, I'll go through it very fast. We have to mitigate the increasing cost of claims due to catalytic fines. We have also got to meet the global requirements. One of the reasons which I slipped on mentioning earlier, why the catalytic fines were more, is because the regulations which were coming in were for low sulfur emission, which have been becoming a mandatory criteria. As the sulfur level in the fuel has to reduce, it has to go through further processing. To further process, you need to have more catalyst, and the possibilities of having more catalytic fines increases with the demand for low sulfur in fuel oil. So we got to meet the global environments requirements, find remedial measures to counter the challenges, and be having continuously proactive debates at all levels to find a amicable solution to this problem of catalytic fines. So gentlemen, and of course ladies who have increased now, do we continue to try and fit square pegs in round holes, or do we attempt to make the pegs rounder and fit them? Do we choose litigation, or do we opt for mitigation? We have no choice. Thank you very much. Keep coming.
Would you mind staying and taking some questions if people have
Yes,
questions?
any questions?
Yes, obviously.
Just what you said about if you perform good drip sampling, according to your experience, if you send the samples to DNV, fuel lab, do they always find the cat finds in the analysis?
To be honest, no. One of the things is what happens on ships, we have seen on a practical basis. The samples are taken and the ship sails out. The bunker supplier changes. Many a time there are compulsions on the ship. They can't be taking those samples in separate tanks. Ideally, if I take bunkers today and I send the samples out for analysis, I shouldn't be using this bunker till I get the sample report. Yeah. Even the lab analysis is not able to pinpoint the cat finds 100%. That is one of the challenges which the industry is facing, and I have come across during the research work some more equipments which are coming in which can trap these cat finds up to 10 microns. It's not very rampant in the market, but the ones who take the initiative and bring it in will be the leaders. They will be very, very proactive in this matter. So yes, the answer to your question, does the lab give a very representative answer? No.
Thank you. In fact, a practical problem that we recently is with the economies going down, many ships are operating with bunkers just as much required. And it's the very fact that you said that the practical way to do it is not to use bunkers till they are not tested. I think this is just not being followed, because we are seeing ships which are taking just about that much bunker required for a round trip.
True.
It becomes impossible for the master or the chief engineer of the vessel to actually follow this.
Exactly. It's a hypothetical thing, but ideally speaking, it should be done. There should be a facility, they should have additional tank, there should be some arrangement. I mean, these are all things which has to be debated on a very proactive basis, and a solution has to be found on this. No questions.
Surely every self-respecting chief engineer would have enough sleeve oil
Yes.
to allow him to run the ship for however long it takes to get the laboratory analysis. So if the chief engineer doesn't, then he's not doing his personal job properly.
True, but then that is again going to be a problem for the underwriters. I mean, the liability aspect shifts there. Due diligence is one thing, but improper maintenance or standards of maintenance are totally different. So the liability aspect does shift there, and that is a big challenge. I wonder if any underwriters are here, they are going to be facing. How do you attribute the damage? Because the bunker suppliers have changed, the ports of loading have changed, the tanks have had mixed bunkers. So it is a big time challenge and has to be addressed correctly. Yes, sir.
Yes. I was wondering how the other industries, other than the marine, how for example, the automobile industry is dealing with this problem, or is it just something unique for marine engines?
No, they must be having their own R&D department to the marine industry, like cat finds have been identified from the 1980. But there have been times during the war, I mean in the 70s, our research revealed that in the 70s the cat finds increased because there was a absolute, especially it originated from the Middle East because there was no oil supply and the demand was very high. So substandard bunkers found their way. So in the industry, like aviation industry, must be having their very high standards of R&D and due diligence. I am not too sure about that. But about marine industry, there is still a gap between the cup and the lip is really, really very wide.
Right, well, I'm sorry we've run out of time for any more questions, but Uday's done a lot of work on this topic, and I'm sure he's happy to talk to you about it in the outside
Anytime.
sessions.
Anytime, yes.
Well, can we thank Uday for his wonderful presentation?
Thank you.